So we're going to review how to graph sine and cosine functions. So on Thursdays and earlier in the week, we spend time graphing the sine function and the cosine function in detail. Now I'm just going to kind of teach you a shortcut. And when we're doing this shortcut, we're focusing on the 90-degree multiples or the 90-degree multiple angles. And when we do this, for the sine function, we want to remember that our pattern is middle, high, middle, low, middle. So my middle value is 0 because my graph normally has a middle at y equals 0. My high point is 1, my middle is 0, my low point is -1, and then my middle again is 0. So when I'm plotting this on the grid, I'm going to go middle, high, middle, low, middle, and then I carefully connect the function into a nice curve like a wave. Now if I wanted to extend this graph, what I like to do is I normally like to do another interval of 2 pi, and then I go middle, high, middle, low, middle, and I like to use another color just so you can see the difference between each cycle. Okay, now as I keep going on the right, I go middle and then keep going to high. So the high would happen 3 tick marks later, which is 1, and then that's sort of the end of my graph on this side. And then middle, high, middle, low, middle. So there's the low or the middle and the low. So there's my graph on this side. So one cycle would be represented in red, or even the pink. One cycle of y equals sine theta. Now we have talked about all of the characteristics before. My period is 2 pi. It's the length of time it takes for one cycle. My domain would be, well, when I look at this, my red graph is one cycle, and that cycle continues forever to the right and forever to the left. So my domain would be -infinity to +infinity using interval notation. My highest and lowest coordinates for y are +1 and -1, so my graph has to stay within 1 to -1 for my y's, including 1 and including -1. Now x-intercepts, you need your general formula for this. So what we're going to do is write out our x-intercepts, which is at 0, pi, 2 pi, ... So my starting x-intercept is at 0, and then it sort of repeats itself every pi unit. So it's going to repeat itself, so I'm going to add on multiples of pi, and then n can be an integer. So this is my x-intercepts, and you can drop the 0, but I'm just going to show it. That's sort of your starting angle, and then keep going from there. And my y-intercept is 0, 0. Okay, key functions, or the key function is sine theta. You need to kind of remember these characteristics for this base function, and then we move on to transformations from here. Okay, cosine function, same way, we're going to deal with it. We're only going to focus on the 90-degree multiples to help you graph the function. And you have to remember, cosine has a high, middle, low, middle, high pattern. So it's going to have the high, middle, low, middle, high pattern. That might help you remember the ones and the -1s. And then I'm going to carefully graph that on the grid. So high, middle, low, middle, high. If your graph doesn't go through the correct points, you won't get correct marks on a test. So then again, high, 1, 2, 3, middle, and then I can't show any more on that side. I like to do my cycles in different colors, so high, middle, low, middle, high, and then, whoops, yep, that's right. And then we're going to carefully draw that function in. That's another cycle. And then again, we're high, middle, low, middle, high. So we're kind of working backwards, and I can just kind of stop it there. So this would be my cosine function, and one cycle is represented in red. That's my kind of my traditional cycle which is 2 pi, which is like going on the unit circle from 0 to 2 pi. Okay. Characteristics, my period is 2 pi. Domain, same as the sine function, minus infinity to plus infinity. My range would be between -1 and 1. This is literally the same, except the x-intercepts are different. My first x-intercept is pi over 2. My next one is 3 pi over 2, comma, dot, 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 and then obviously in the negatives and the positives. Now, if you remember, pi over 2 is like a 90, and 3 pi over 2 is like a 270. So the difference between these two is like 180, which is pi units. So when I describe my x-intercepts using my general formula, it would start at pi over 2, and then it would repeat itself every multiple of pi afterwards. So it's going to land on the 270 and the 90 mark every time you go around the unit circle. And my y-intercept is 0, 1. Again, these are key characteristics that you need to know every time you graph sine and cosine. Now, we briefly talked about amplitude, and when you think of amplitude, we're taking either our sine function or our cosine function, and we're adding the a value out front. And when we add the a value out front, we're really referring to a vertical stretch by a factor of a Now I want my a to be strictly positive, so I'm going to put an absolute value around it about the x-axis. And if my a was negative, then we're just referring to the reflection in the x-axis. So we never talk about our amplitude being negative. The negative is the reflection. The amplitude is still the same thing as your vertical stretch factor. But instead of calling it a vertical stretch, we're going to call it amplitude, but in your mind, you know it's the same thing as a vertical stretch. Okay? Now, when we complete the table, this row of the table is kind of like key information that you need to remember. My amplitude is a 1 in normal sense, in the normal case, and you have to remember your amplitude is coming from the number out front. So if I just look at my vertical stretch factor, this is like a 3, this is like my 1/2. So I'm just reading it off the equation. My domain is normally minus infinity to plus infinity. My range is normally -1 to 1, and my period is normally 2 pi. Now, when I put a 3 here, it's like doing a vertical stretch by a factor of 3, so my domain doesn't change because the vertical stretches don't affect the x-coordinates, but my range is like y-coordinates, so I'm going to multiply my y-coordinates by 3. So my new range would be -3 to 3. And then again, a vertical stretch by a factor of 3 doesn't affect my period. Same idea. Domain and range stay identical. Period stays identical. But my range is going to go from -1/2 to +1/2. Now, when you're drawing the graphs, this pattern has middle, high, middle, low, middle on it. And they're all going to have the same pattern. But this time, my high and my low point are changing because the x-intercepts are invariant under a horizontal or a vertical stretch. So what I'm going to do is I'm going to draw the sine function using a red color, the 3 sine x function using pink, and then the 1/2 using green. Okay, so middle, high, middle, low, middle, and I draw my 1 cycle. Now, if they want you to draw more than 1 cycle, that's fine. You're just going to extend that infinitely to the left, infinitely to the right, following the same pattern, the middle, high, middle, low, middle pattern. When I want to do 3 sine x, I do middle. My high point now changes to 3. My middle stays the same because that's invariant. My low point changes to -3, and then my middle stays the same. So there is my sine graph. It increases the kind of the depth of the wave, but other than that, it keeps my x-intercepts the same. When I do sine of 1/2 x, middle, high, middle, low, middle. So there's my graph in green, which is the y equals sine 1/2 x. I literally would pick up the green graph, move it infinitely to the left, infinitely to the right. I'm just going to make a note, only one cycle drawn. Now, if they want you to continue, I like to use another color and just continue it on to the left or to the right, but I'm going to focus on my domain to be just 0 to 2 pi, so you can focus on one cycle and what it looks like. So again, when you think of amplitude, you're thinking of the same thing as a vertical stretch by a factor of a, well, absolute value of a. And if the a is negative, we have a reflection in the x-axis. Now, if I have a reflection in the x-axis, my pattern is just going to reverse. Middle, low, middle, high, middle. Now, when I'm doing a change in period, this is a change in my b value. I'm doing a change in my b value. So this is like your horizontal stretch by a factor of b. Now I said b, but I meant 1 over b. And again, we don't read the b value as being negative. If there's a negative, we would refer to a reflection in the y-axis. Okay. Now, most of the time when I see questions being presented in terms of the b value, we really refer to the graph having a change in period, but we also talk about the horizontal stretch. But I don't see the questions being presented where they put a negative in terms of the b for the reflection in the y-axis, but it can happen. Now, this spot is sort of like key information that you have to remember. My domain is minus infinity to plus infinity. My range is -1 to 1. My period is 2 pi, and my amplitude is 1. Now remember, amplitude is the number in front of the coefficient of the term. So it's out front like a y change. These are all 1s, so therefore my amplitude is all 1. I don't have a vertical stretch happening. My range is a y change, so nothing is going to happen to my range. However, this is an x change, and this is an x change. So we want to remember that this 3, my b value is 3, so this is like a horizontal stretch by 1/3, and this is like a horizontal stretch by 1, or not by 1/2, by 2. And so literally my x's get multiplied by 2. Now, when I have an infinite domain, multiplying by anything is not going to change that. My domain is still going to be from minus infinity to infinity. If I do a horizontal stretch by 1/3, my period gets multiplied by 1/3. So my new period is 2 pi over 3. And then if I do 2 times 2 pi, then my period becomes 4 pi. So your period will always be represented using the formula, which is not on your formula sheet, 2 pi over absolute value of b. Or if you're in degrees, 360 degrees over my absolute value of b. Now, when I'm graphing this function, the part that you want to pay attention to is how we're graphing it. So we're going to do a high, middle, low, middle, high pattern. But basically, this is one cycle for cosine, high, middle, low, middle, high. Now I'm going to do the same thing, high, middle, low, middle, high, but I want that full cycle to complete within 2 pi over 3. So 2 pi over 3. So this is where you have to be fancy on your scale. So I have a pi over 2 here, and it's broken into 3 parts. So my pi over 2 gets divided into 3 parts, which simplifies to pi over 6. So each tick mark is pi over 6. So we're going to count, where is pi over 3? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So now I know that 4 pi over 6 is the same thing as 2 pi over 3. So what that's telling me is my high, middle, low, middle, high pattern has to be done within 2 pi over 3, which is this point right here. So I'm going to do my high and high. The halfway point would have to be my low, and then the halfway point and halfway point have to be my middle. So there's my cycle. It's 1/3 the length. So if I look, high, middle, low, middle, high, there's 2 cycles, high, middle, low, middle, high. I'm ending up with 3 cycles in 2 pi. So this 3 means 3 cycles in 2 pi. This 1/2 here means I only complete 1/2 a cycle in 2 pi. So what I want to really do is I want to think of this, and I'm just going to move this kind of to the side here. I want to think of my axes, and I'm going to kind of just extend it kind of grossly. This distance is approximately, I'm going to say that this is 4 pi hypothetically. So when I know that my period is 4 pi, I want to take 4 pi units to complete 1 cycle. So what I'm going to do is do my high, middle, low, middle, high pattern to take a full 4 pi units. So I'm going to do my high and high for the full 4 pi. Half of 4 pi is 2 pi. So my low is going to be here. Half of 2 pi is pi, and in between here would be 3 pi. So it's taking me half the length of time to do half a cycle, and then I complete 1 full cycle in 4 pi. So I only complete half a cycle in 2 pi. So high, middle, low, and then middle, high is half my cycle, and now I complete the full one in 4 pi. So again, I extend my axes to make it look like my full cycle is completed in 4 pi units. Now again, if I wanted to extend these graphs, I pick up the green graph, pick up the purple graph, pick up the black graph, and move it infinitely left, infinitely right to help describe that. So this is 1 cycle shown. Now it's really important that you always show 1 cycle, because that's kind of the key aspect of what's happening. If you can't show me 1 cycle, then you don't really know what's happening in terms of the graph. So just remember, it needs to do the high, middle, low, middle, high from 0 to 4 pi, and then 2 pi would be in the middle, and I'd be counting by pi, 0 pi, 2 pi, 3 pi, 4 pi, and then my high, middle, low, middle, high is 1, 0, minus 1, 0, 1, because that's sort of my amplitude indicating to me in terms of what's happening. Now in this one, you're doing your high, middle, low, middle, high, and we want the full cycle to take 2 pi over 3 units. So I would say, okay, 2 pi over 3, half of 2 pi over 3 would be 2 pi over 6, and then half of 2 pi over 6, well, this would be 1 pi over 3, so 2 pi over 3, half of it is 1 pi over 3, half of pi over 3 is pi over 6, and then pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, high, middle, low, middle, high, because my amplitude hasn't changed. So be very careful with how you're plotting those. It is a little bit tricky. If you don't like this, you're going to take your 5 main points, which are your 0, 1, pi over 2 and 0, pi and negative 1, 3 pi over 2 and 0, and then 2 pi and 1, and then just apply your mapping notation just like you would have in the transformations. Okay, so this is like an OR. Okay, so the 2 things we're going to focus on are the new ideas, amplitude, period. Remember, this is like your A variable, but in absolute value. This is like your B variable, sort of, but in absolute value, okay? Sort of, okay? So there is my A value. So A is equal to 3. This is my B value, B equals 6. So there, my amplitude would be equal to 3. So my period would be, it normally takes 2 pi to do my cycle, but now it gets divided into 6 parts. So my one period is pi over 3 units long. So when you're thinking of period, it relates to B. So my period formula is always 2 pi over B in absolute value. Okay, so my high, so this one is my middle, high, middle, low, middle pattern is kind of happening in a length of pi over 3 units. And then you would draw that in if you needed to. In this graph, we have a reflection in the x-axis. Now I'm thinking of my cosine pattern, but reverse. So my cosine pattern is high, middle, low, high. But now I reverse it, low, middle, high, middle, low. So it's going to do a low, middle, high, middle, low pattern. My amplitude is 1/2. And then my B value is 1/4. Which means I'm getting 1/4 of a cycle in 2 pi. So my period is equal to 2 pi over my B, which is 8 pi. So it's going to do a low, middle, high, middle, low pattern in 8 pi units, which means I'm going 0 to 8 pi. The halfway point is 4 pi. The halfway point to that is 2 pi. So 0, 2, 4, 6 pi, 8 pi. And then the high point is going to be my 1/2, and my low point is going to be minus 1/2, because that's kind of what my amplitude is telling me. Describe the transformations required to get the above functions. So now we're just treating it like transformations. So in part A, we have a vertical stretch by a factor of 3 about the x-axis. And I have a horizontal stretch by a factor of, and I'm going to look at my value, which is 6, and then I'm going to invert it 1/6 about the y-axis. Okay. In this example, I have a reflection in the x-axis. I have a vertical stretch by a factor of 1/2 about the x-axis, and a horizontal stretch by a factor of, I look at my B value as 1/4, I reciprocal that 4 about the y-axis. So you have to remember that when we're doing transformations on these functions, none of the rules change to what we've already learned. We're kind of already done, and we just kind of follow the same skills that we've already followed up until this point. So that's going from an equation to words. What if they give us the words and we have to go back to the equation? So when they say find the sine equation, we're going to write a sine function. The amplitude is 1/3, so I know my A is 1/3. My period is 4 pi over 3, but I use the relationship I know. So period is 2 pi over B, and I'm going to sub in my period. 4 pi over 3 is equal to 2 pi over 6. Whoops, I wrote that wrong. I was thinking, so my period formula is 2 pi over b. So I'm going to write this as period. I already know my period is 4 pi over 3 equals 2 pi over b. And now I'm going to cross multiply to solve this. So 4 pi times b is equal to 2 pi times 3. So 4 pi times b is equal to 6 pi. I want to get the b by itself, so I divide both sides by 4 pi. And I get that this is 3 over 2. So when I write my equation, I have my a value, I have my b value, so y is equal to a sine, my b is 3 over 2x. So basically the key idea is that you need to know that your period is 2 pi over b, and you just use that relationship to help you solve for the b value. The a value is clear, and they'll just kind of tell you that. So this is just kind of focusing on the a and the b value, and we're also going to focus on the h and k value, kind of like your translation and your vertical and horizontal translations. But we're going to do that in the next lesson, and we're going to learn new words for the horizontal and vertical translation, but it's no different than the old words we've already learned. We're just making some comparisons. Okay, so we'll do that in the next lesson.